All right, there's one more theorem we need to discuss really quickly. Okay, and that is this one, the trapezoidal mid-segment theorem. Or trapezoid mid-segment theorem. Okay? All right? So, what does that exactly mean? Well, let's say that I have a trapezoid. Okay? Of varying size and shape. This is not a perfect to scale mock-up. This is just for an example. Okay? So, all of these lines are parallel. Can we agree on that? Yeah? Okay, they're all parallel. Boom, boom, boom. Okay? Let's give these guys some points. We're going to call this X. We're going to call this Y. We're going to call this Z. And we're going to call this W. And it is divided down the middle. I know it's not exactly scale. By A and B. Okay? So, what we can state down here is that line XY is parallel to line AB, which is parallel to line WZ. That is how a trapezoid works. That's because it's a parallelogram. Two lines have to at least be parallel for anything to be a parallelogram. That is a given fact. That is the definition of parallelogram in a nutshell. That's why squares and rectangles. Squares are right angle parallelograms, or they have a funky name. That's why we classify them. They're like the perfect parallelogram. Okay? And because of this, this is the equation we can get from this. AB equals 1/2 of XY plus WZ. This is congruent to this. This is congruent to this. Okay? There is the trapezoidal mid-segment theorem. Very important to have in this little booklet. All right. Almost forgot about that in the notes. I'm glad I